This is our last video on relative velocity. A ship goes 35 degrees north of east, poking along at 7.5 meters per second relative to the ocean current. All right, so let's start writing some things down. The velocity of the boat is a ship, ship is a boat, relative to the current is 7.5 meters per second at 35 degrees north of east. The current flows 2.8 meters per second north relative to a nearby landmass. The velocity of the current relative to the land is 2.8 meters per second north. A sailor walks across the ship's deck at 2.3 meters per second in the direction 45 degrees west of north. The velocity of the sailor relative to the boat is 2.3 meters per second at 45 degrees west of north. And what we want is we want the velocity of the sailor relative to the land. Let's see if we need to flip any of these vectors that are given, or maybe we just use them as is. And so the way we do that is we always make sure that the first letter matches up here. There's an S, there's an S. Velocity of the sailor relative to, what do we have? The boat, all right? And that won't get us the answer, so we need to put another term here. And we definitely know that the first letter for this one has to be the boat, because birds of a feather flock together. It looks like the one we're given is the velocity of the boat relative to the current. That still doesn't get it done for us, so let's keep going here. And we know that those C's need to match up. And how about that? That looks good. See that? We started with an S and we ended with an L, just like we need to. And in between here, we make sure that those match up. It looks like, in this case, we don't need to flip any of these vectors backwards. We can just add them as usual. Now, when you add vectors, it doesn't matter in which order you add them. The point of this bottom line is to make sure that you know, should I just keep the vectors that I have and add them, or do I need to take the opposite of one of them or two of them or something like that? So now it's simply a matter of adding these vectors and getting a final result. Now, when we sketch this first vector out, 35 degrees north of east, why don't I kind of graph that? East is to the right, so there's east right there. And 35 degrees to the north of that would kind of go like that. So there's 35 degrees to the north of east. And if this given is 7.5 meters per second, then what we need to do is we need to break it into components. And I'll make one component look like that. And why don't I make the other component? Well, you can't really see that probably in the video, but that's supposed to be purple. Anyway, using sine and cosine as appropriate. I'm not going to go through how we do that here, but hopefully you know that already. This comes to 6.14 meters per second. That would be the easterly component. And then 4.30 meters per second is the northerly component. This vector is entirely in the northerly direction. So this 4.3, to it, we're going to end up adding a 2.8. That and that are going to be added. And then what do we have down here at the bottom? This is 45 degrees to the west of north. North is that way. So 45 degrees to the west would be like that, where this angle right here is 45 degrees. And if this hypotenuse is 2.3 meters per second, then the various components are equal to each other. That one there is equal to that one there, and they both have the magnitude, according to what I calculated here, 1.63 meters per second. So let's look at what we have in the northerly direction. 4.3 to the north, 2.8 to the north, and 1.63, all to the north. When we add those up, that gives us a total of 8.73 meters per second to the north when we put those three vectors together. Now, what about in the east-west direction? In the east-west direction, do you see here that this 6.14 points to the east, but this 1.63 points to the west? So we have to subtract those. And when we do that, we end up with a result of 4.51. Those two put together give us 4.51 because we have to subtract those meters per second. And who's going to win here? It looks like east is going to win because east is the bigger number. The west number is smaller, so that is a resultant east. So now all we have to do is Pythagorize these. Let's go ahead and draw them out. How about 8.73 meters per second north and 4.51 meters per second to the east? So that might look kind of like that. 4.51 meters per second east. And so our resultant vector looks like that. And since this is a vector, we would have to give an angle, and we do it at the beginning of the vector. And the result I got, you go ahead and check it. If we use the Pythagorean theorem on this to two significant figures, I got 9.8 meters per second, and then this angle here is 27 degrees east of north. If you had drawn the 4.51 vector first, and then the 8.73, then you would have gotten this angle that I'm pointing to with my pen right now. Let me go ahead and we won't do all that work, but I'll just point to the angle. And then you wouldn't have reported it as 27 degrees east of north. You would have reported it as 63 degrees north of east. But that's the exact same direction.